Alright folks, so today we're going to talk about ions, and ions are just charged particles. Now ions come from atoms, and all atoms are neutral. Alright, so it has the same number of protons that it has electrons. So if I ever ask you how many electrons are in an atom of, let's say, magnesium, well, we can look at the periodic table and see that the atomic number for magnesium is 12, which means it has 12 protons, which also means it has 12 electrons. And since those positive charged protons and those negatively charged electrons are equal in number, that means they balance out, and there is no charge on the atom, and it is neutral. So atoms can gain or lose electrons, and that's when you're going to see a positive or negatively charged ion. Now, the charge of an ion, we're going to write those as superscripts on the upper right of the atom symbol. So we see the calcium 2+, the nitrogen 3-, and the lithium plus. And since there's no number there with the lithium, it's an understood 1. So let's take a look at calcium here. So calcium has 20 protons and 18 electrons. So it has the charges 2+ more of the on the positive side. And nitrogen has 7 protons and 10 electrons. And so it has 3 more on the negative side. And lithium, 3 protons and 2 electrons. So it has 1 more on the positive side. Take a moment, break this down in your head, and write down these examples as well in your notes. Now we can use the periodic table to find out how many or what the charge is for all of these ions. And so it's really easy. The group 1 ions, they all have the 1 plus charge there. And group 2 are 2+. We go all the way over to the other side and we look at group 18, and that's 0. So these are not going to have ions. And these are those noble gases we talked about. We take a look at group 17, the halogens, and they have the 1-. And we look at oxygen group, 2-, and so forth. So use the periodic table to your advantage. Again, memorize that kind of stuff. It's easy to memorize because it basically follows the numbers on the metal side. On the non-metal side, we start at 0 all the way on the right and then work our way to 1, 2, 3, 4. So we have a few examples here, and take some time when we go through these. Pause the slideshow, write them down, and see how well you do. So for calcium, the calcium atom and the calcium ion. All right, we have 20 protons, so we're also going to have 20 electrons, and that means it's going to be neutral. But the calcium ion has 20 protons. How many electrons? Take a look at the periodic table. What do you think? Well, it should be 18, because you should have also memorized that from the previous slide as well. So it has the 2+ charge. All right, so it's going to have the symbol of Ca2+. So the 2+ charge of the calcium ion tells us that it has 2 more protons than electrons. Not that we added more protons, it's just that it has 2 more protons than electrons because we lost electrons. Now phosphorus. Let's work through phosphorus here. The phosphorus atom has 15 protons and 15 electrons, so it's neutral. Atoms are neutral. And so we're going to write that symbol as P. Now the phosphorus ion has 15 protons. How many electrons does it have? Find phosphorus on your periodic table, find the group that it's in, and what's that charge going to be in that group. If you wrote down 18 electrons with a 3- charge, you are correct. It has the symbol of P, 3-. So remember, the number of protons is given by the element's position on the periodic table, the atomic number, and that number cannot be changed to form an ion. Only the number of electrons changes. Now there are 2 kinds of ions. There are cations, and those are metals that form the cations. They're positively charged, and they form when an atom loses electrons. So cations have fewer electrons than protons. So again, cations are only from your metals. They're positively charged, and they form when an atom loses electrons. Examples here, calcium was one of them, lithium, magnesium, aluminum. Anything with a positive charge for an ion, that's a cation. Now, anions, you thought I was going to say dog ions, didn't you? Nah. Anions, they form from the nonmetals. negatively charged, and they formed when an atom gains electrons. So it's the opposite of cations. Pretty easy to remember that. And so anions will have more electrons than protons. Examples: oxygen, chlorine, nitrogen, sulfur. So we have an equation that we can use to find out the formation of these ions, and they follow a simple format: reactants to products, like all of the chemical equations that we're going to see here. So you start with the atoms, and you're going to end up with ions. All right, so let's do this. We have fluorine here, so let's take a look at an anion formation equation. So fluorine plus a free electron. Okay, so when a nonmetal gains an electron, it's going to combine with that atom, that neutral atom, and it's going to move to the right side, and we can see on our product side the fluorine charged ion there. Now, since it only gained one electron, then that's why it only has the F minus, with the minus being the understood 1. So 9 protons, 9 electrons for the fluorine, 1 free electron, gives us 9 protons and 20 electrons now for the fluorine ion. Now let's take a look at a cation formation equation. This time the electrons are on the reactant side because they're being released. They're not being gained. Remember, cations are formed when the atom loses electrons. So we have the neutral atom on the left side, and it loses electrons, and so now it becomes calcium 2+, and then we also have the 2 electrons as well that are being lost on the product side. So we have 2 free electrons there. 20 protons, 20 electrons, 20 protons, 18 electrons, and the 2 free electrons there. Everything is accounted for. So, a little summary here on ion formation equations. Atoms always go on the left side, and ions always go on the right side. If electrons are gained, they go on the left side. If electrons are lost, they go on the right side. So let's talk about naming these cations. So they're named just like the atom. Example, calcium, or the Ca2+ is named the calcium ion. Lithium plus is named as the lithium ion. Pretty easy to remember that. Now anions, a little bit different. We're going to replace the ending of the atoms with IDE, ide. For example, fluorine is not called the fluorine ion, it's called the fluoride ion. And sulfur is not the sulfur ion, it is the sulfide ion. Oxygen would be oxide. And that's it. So let's do some more work in class and see how you do.